Hello students, welcome to Engineers Academy. Now we are going to solve this particular problem which says that determine the force in member CD. So this is CD, CJ, GJ and CG. So we will solve this particular problem by using the method of sections. So we will pass a cutting section here which will divide this truss into two parts, right? And this cutting section need to pass through those members in which we are interested to find their forces. So this is CJ, GJ, CJ and CD. So we will find these three and then we will apply the method of joint to find that CG force. So if I pass a cutting section, after that I am going to consider this right hand side of this cutting section. So this will be a free body diagram, and if we are considering this right hand side, then we need to determine the reaction forces at this point E. We are not required to determine the support at this point A, we are only required to determine the reactions, the supports at this point E. So since this is a pin joint, so we will have two reactions. So this will be EY reaction here, and here we will have EX reaction. And to find this EX and EY, we need to consider the whole truss. So if I apply the summation of moment about, or if I apply the summation of forces along the x axis is equals to 0, if this is my positive x and y direction. So as we can see that all the external forces are acting in the vertical direction, that is in the negative y direction. So the summation of forces along x will give us Ex equals to 0, since there is no other force along the horizontal direction. So Ex reaction is 0. So we can remove this. Similarly, if I apply the summation of moment about point A equals to 0, so the support reaction will not come into our equation, right? So this is, let's say, Ay. So if we apply the summation of moment about point A, so as we can see that this Ey is producing the counterclockwise moment about that point A. So if we assume that the counterclockwise moment is positive, so Ey is producing the counterclockwise moment, and its perpendicular distance from that point A is 1.5 times 4. So this comes out to be 6 meters, right? So we will multiply it with 6. Similarly, this 6 kilonewton force is producing the clockwise moment about that point A, so I will write minus 6. And again, the moment arm of this 6 kilonewton force is 6 meters from that point A, so I will multiply it with 6. This 9 kilonewton force is producing clockwise moment, so I will write minus 9. And the moment arm of this 9 kilonewton force is 1.5 times 3, so this will be 4.5. Similarly, this 12 kilonewton force is again producing clockwise moment, so I will write minus 12. And the moment arm of this 12 kilonewton force from that point A is 1.5 plus 1.5, so this is 3. And similarly, this 6 kilonewton force is producing the clockwise moment, so I will write minus 6. And its moment arm from that point A is 1.5, so I will multiply it with 1.5. And this 4 kilonewton force and this Ay, since they are passing through this point A, so they are not going to produce the moment about this point A. So this will be equal to 0. So now if I calculate this, so this is, if we bring all these terms to the other side of equation, so they will become positive. So we will have 6 into 6 plus 9 into 4.5 plus 12 into 3 and plus 6 into 1.5 and divided by the moment arm of Ey. So we will divide it by 6. So Ey comes out to be 20.25 kilonewtons. So Ey is 20.25 kilonewton. Now we will apply the method of sections. So this is our free body diagram. So this will be CJ member force. Let's say that I represent that by CJ. This will be GJ, sorry, this is GJ and this is CJ. and this will be CD. This is CD. So now if I apply the summation of moment about point C equals to 0, so as we can see that this Cj and this CD, they are passing through this point C, so they will not produce the moment about that point C, so they will not come into our equation. And to find the moment of this Gj about that point C, we need to resolve this Gj member force. So it will have two components. It will have one component like this, and it will have one component which will be acting vertically upward. So it will have one component like this. So we need to have this theta. So this Gj, if I draw a line here, so this Gj is making that angle theta here. So as we can see that this length is 1 meter, then this is 1 meter, and this whole length is 2 meters. So this length is 1 meter as well, and this length is 1.5. So we can find this theta. So if I apply tan theta, so tan theta is this perpendicular divided by base. So this is 1 divided by 1.5. And if I take tan inverse, so we will be able to find that angle of Gj member with the horizontal. So tan inverse 1 divided by 1.5. So this gives us the angle equals to 33.69. So angle is 33.69 degrees. So now this is Gj cos of theta, this is Gj cos of theta, and this is Gj sin of theta. So now as we can see that if I apply the summation of moment about point C, so both of these will not come into our equation. So this cos component is producing the counterclockwise moment about this point C if we apply the summation of moment about point C. So I will write Gj cos of theta, and theta is 33.69, and its perpendicular distance or the moment arm of this cos component from that point C is 1 meter. So I will multiply it with 1. And similarly, this sine component is producing the counterclockwise moment about that point C. So I will write plus Gj sine of 33.69, and the moment arm of this sine component from that point C is the length of the CD member, which is 1.5. So I'll multiply it with 1.5, and this 9 kilonewton force is producing the clockwise moment about that point C. So I will write minus 9, and the moment arm of this 9 kilonewton force from that point C is 1.5. Similarly, this 6 kilonewton force is producing the clockwise moment, so I will write minus 6, and the moment arm or the perpendicular distance of this 6 kilonewton force from that point C is 1.5 plus 1.5, so that is 3. And here we have that support force as well, that Ey, and this Ey, as we have determined that this is 20.25 kilonewton. So again this Ey is producing the counterclockwise moment about that point C, so I will write plus, this is 20.25, and the perpendicular distance of this Ey from that point C is 3. So this will be equal to 0. So cos of 33.69 is 0.832. So I will write 0.832 Gj plus 1.5 into sine of that angle. So 1.5 multiplied by sine of 33.69. So this is 0.832 again. So 0.832 Gj. If we add up both of these, so this will become 2 times 0.832 Gj. And similarly, we can simplify this. So this is minus 9 into 1.5. Minus 6 into 3, and plus 20.25 into 3. So this gives us 29.25. So 29.25, and this is equal to 0. And if I bring this to the other side of equation, so it will become negative. And if we divide both sides of equation by 2 into 0.832, so we will be able to find that Gj member force. So this is, we can say that answer is that 29.25 divided by 2 into 0.832. So this will be minus 17.57. So Gj equals to minus 17.58 kilonewton, and the negative sign indicates that the assumed direction is not accurate, since we have assumed that these three members are in tension, but the sign is negative. So this means that Gj member force magnitude is 17.58 kilonewton and it is in compression. Now if you want to find the CD member force, so for that we can apply the summation of moment about point J equals to 0. So as we can see that this CD force is producing the clockwise moment about that point J, so I will write minus CD, and the perpendicular distance of this CD from that point J is 1 meters. And as we can see that the line of action of this Gj and this Cj, they are passing to that point J, and line of action of this 9 kilonewton force is passing to this point J, so they will not come into our equation. So we will have this CD and this 6 kilonewton force and this Ey in our equation. So this 6 kilonewton force is producing the clockwise moment about that point J, so I will write minus 6, and the perpendicular distance of this 6 kilonewton force from that point J is 1.5, so I will multiply it with 1.5. And similarly this Ey is producing the counterclockwise moment about that point J, so I will write plus, and this is Ey, its magnitude is 20.25, and the perpendicular distance of this Ey from that point J is 1.5, so I will multiply it with 1.5, and this is equal to 0. And if I bring these two terms to the other side of equation, so their signs will become negative, and we can determine it, we can determine this by using calculator. So this is 6 into 1.5 minus 20.25 into 1.5, and if we divide it by minus 1, so CD comes out to be, CD is 21.38, so 21.38 kilonewton, and the sign is positive, so this means that the assumed direction of CD was accurate. So this means that the CD member is in tension. Now if we apply the summation of moment about point E equals to 0, so again as we can see that this Gj force is passing through that point E, and this CD force is passing through that point E, so they will not produce the moment about that point E, so they will not come into our equation. And to find the moment about that point E, again if I resolve this Cj member force into its component here at point C, so we will have two components. So if this Cj force will have one component in this direction at point C, and it will have one component in this direction. So if we have determined that angle theta, so if this is that angle theta, right, and if this is that angle theta, so this triangle and this triangle, they are similar triangles, so this angle is also theta. And if this angle is theta, so this angle is also theta, so all these triangles are similar triangles, right? So we can say that this Cj is also making that same angle theta here. So now if this is theta, then this is the cos component, this is, we can say that this is Cj cos of theta, and this one is Cj sin of theta. So now as we can see that this cos component, the line of action of this cos component is passing through that point E as well, so only this will come into our equation. So we can write that Cj sin of theta, it is producing the counterclockwise moment about that point E, and the perpendicular distance of this sine component from that point E is 1.5 plus 1.5, so it is 3, and theta is 33.69. Now let me remove this cos component since it is not producing the moment about that point E, and this CD is also not producing the moment about that point E. So we are left with this 9 kilonewton force and this 6 kilonewton force. So this 9 kilonewton force is producing the counterclockwise moment about that point E, so I will write plus 9 and the moment arm of this 9 kilonewton force from the 8 point E is 1.5, and similarly this 6 kilonewton force is passing to that point E as well, and this EY is passing to that point E as well, so they are not producing the moment about that point E, so this will be equal to 0. So from this we can solve it. This will be, if I bring this to the other side, so its sign will become negative, so this will be minus 9 into 1.5, and if I divide it by 3 sine of this, so we will be able to find that Cj member force. So this is minus 9 into 1.5 divided by 3 sine of 33.69. So this gives me minus 8.11. So Cj is minus 8.11 kilonewton, and again we have that minus sign, so this means that the initial assumed direction is not accurate. So this means that the Cj member is in compression and the magnitude of the compression is 8.11 kilonewton. Now to find this Cg member force, we will apply the method of sections at point G. So we will consider this point G for equilibrium. So if we are going to consider this point G, so this Gj member force we have determined it is the compressive force, so now it will be acting towards the joint. So this is that Gj member force, and its magnitude is 17.58. So let me write it here. This is 17.58, and similarly let's assume that this Hg member is in tension, let's say. So this is Hg, and this Cg member force is, let's say, this is in compression as well, right? These are our assumed directions, right? So this is Cj. So we are interested to find this Cj. So now this angle is 33.69. Let me write it here, that theta, which is 33.69 degrees. So if this is 17.58, so this is that same angle theta. So this Gj member force is making that same angle theta here with the horizontal. If I resolve this Gj member into its components here, so this is, if this is that same angle theta, since both of these angles are alternate angles, then this is Gj cos of theta, and here we will have the sine component of Gj. This is the sine component, and similarly both of these triangles are similar. So if this angle is theta, then this angle is also that same theta. So if we resolve this Hg into its components, so this one is, again, if this is theta, then this is Hg cos of theta, and here we will have Hg sine of theta, which will be acting vertically downward. So now if I apply the summation of forces along x, if I apply the summation of forces along x at joint G equals to 0. This is at joint G. So as we can see that this Hg cos of theta, this is acting in the negative x, and this Gj cos of theta, it is also acting in the negative x. Let me write. So Hg cos of theta, and theta is 33.69, and this Gj is also acting in the negative x, so I have to write minus here and minus Gj, and Gj magnitude is 17.58, so I will write 17.58 cos of 33.69, and this is equal to 0. So now if we divide this whole equation by cos of 33.69, so it will cancel out, and we can say that minus Hg will be equal to 17.5 kilonewton, and if I multiply both sides by minus 1, so Hg will be equal to 17.5 kilonewton. So this means that the assumed direction of Hg is not accurate, it is in compression as well. So this is 17.5 kilonewton, and it is in compression. Now to find that Cg, if we apply the summation of forces along the y-axis is equals to 0 at point G, so the summation of forces along y equals to 0. So as we can see that this Cg is acting in the positive y, so I will write Cg plus Cg, and this is Hg sine of theta acting in the negative y direction, so I will write minus Hg sine of theta. This is sine component, right? So this is 33.69, and for this assumed direction the Hg value is minus 17.58. So I will write this as minus 17.58. And similarly, this is Gj sine component, so I will write it is acting in the positive y, so I will write Gj, and Gj magnitude is 17.58 sine of 33.69. This is acting in the positive y direction, and this is the sine component, and this 12 kilonewton force is acting in the negative y, so I will write minus 12, and this is equal to 0. So if I multiply this minus sign with minus sign, so it will become plus 17.58. So this is plus 17.58, and they will add up. So this is 2 times 17.58. So we can calculate it. This is 2 times 2 multiplied by 17.58 sine of 33.69 and minus 12. This is minus 12. So this is 7.5. So Cj plus 7.50, this is equal to 0, or we can say that Cj equals to minus 7.50 kilonewton. Again, the minus sign indicates that the assumed direction is not accurate, so this means that Cj member is in compression and it has a magnitude of 7.50 kilonewton. So this is the solution of this particular problem. Kindly subscribe my channel for the solution of such more problems.